Hello dear students, today's lesson is about the solving first degree inequality in one unknown. In the previous lesson, you have learned how to solve the first degree equation in one unknown by using the properties of the equality in two sets, n and z. As here in this example, 2x minus 9 equal negative 5, we said that we can imagine that negative 9 move to the other side. I want to just isolate or put the x in one side and or all the numbers in the other side. And the 9 will move by the opposite operation. Here negative 9 or minus 9 go to the other side by positive 9. Now I have 2x equal negative 5 plus 9, so 2x will be equal 4. And the 2 here multiplied by the x will go to the other side by divide 2, then x equal 2. And the solution set equal 2. So, in this lesson, we will learn how to solve the first degree inequality in one unknown by using the properties of the inequality. So here, let's see, I have an equation. I have an inequality. This inequality, I can say it is inequality because I can see the inequality sign. Here I can read this, x minus 1 smaller than, or you can say less than 4. The x is of the power 1, so this inequality is of the first degree, and I have only one unknown or only one variable, so this inequality is of the first degree and with only one unknown. Let's see how can we solve it, but first we have to know the properties of the inequality in n and z. First property, that when we add or subtract the same integer to or from both sides of the inequality will be true. Like if I have here a greater than b. So if I add c to this side, if I add c to a and add the same c to the other side c, the inequality will be the same. So the answer here will be greater than this side. And if I subtract from this side the number c and from this side the number c, so this side will be still greater than this side. Let's see the second property. When we multiply or divide both sides of an equality by the same positive integer, and be focused that for this word positive integer, the inequality will be true. In this example, if a greater than b, then if I multiplied a and b by the same positive number c, so a multiplied by c will be still greater than b multiplied by c. And the same here, if I divide a by c, will be greater than if you divide b by c. So in the equation, like the inequality, the two sides will not change by adding or subtracting or dividing numbers. But here I have very important property. When multiplying or dividing both sides of an inequality by the same negative integer, the inequality will be true after changing the direction of the inequality sign. What does it mean? It means that if I have A greater than B and I multiplied both sides A and B by a negative integer, by negative C, as an example. So I can say that A greater than B, or this side will be greater than this side. No, I cannot say this. I can say that the sign will change its direction. And the same here, A divided negative C and B divide negative C, the sign also will change its direction. So A greater than B. If multiplied by negative integer, or divide by negative integer, so you must change the direction of the sign. Let's see an example. If I have here 6 greater than 4, this is a true or a valid inequality. If I want to divide both sides by negative 2, so let's see, when you divide 6 by negative 2 and 4 by negative 2, the answer will be here 6 divided negative 2 is negative 3. 4 divided negative 2 is negative 2. So can you say that negative 3 is greater than negative 2? No, it is not true. It's false. So I have to change the direction of the sign, because when I divide the integers or both sides of the inequality by a negative or multiplied by a negative integer, you have to change the direction of the sign. Like this example, 6 is greater than 4. When you divided it by negative 2, the answer will be negative 3 and negative 2. But negative 3 is smaller than negative 2. So you must change the direction of the sign. So I will call this exercise an alarm. I will always remind you by alarm. Okay? Okay. Let's see exercises of the booklet. On the booklet page 49. The booklet page 49. Let's see number B. Find the solution set of each of the following inequalities. And here number B, 2x plus 9 smaller than 1. And we said that the signs of the inequality could be smaller than, greater than, smaller than or equal, greater than or equal. So here I have the substitution set Z. Let's see how can we solve it by using the properties of the inequality. We said that to isolate or make the x stand alone, I have to cancel the numbers beside the x. This is the original method. Here, this is plus 9. To cancel it, I have to subtract 9. But I have to do this on both the sides, from subtract 9 from this side and also subtract 9 from this side. So 9 will go with the 9. So I have 2x greater than negative 8. 1 minus 9 equal negative 8. So by dividing both sides by 2 to make it here like this, I want the x by itself. To cancel these 2, so I will divide this side by 2 and divide this side by 2. And the answer will be here x greater than negative 8 divided 2 equal negative 4. So the solution set, will be, what are the numbers that smaller than negative 4? The numbers smaller than negative 4. I want all the numbers that smaller than negative 4. Can you say it? Yes. Smaller than negative 4, negative 5, negative 6, negative 7, and negative 8. And so on. All of these numbers belong to Z. So, solution set here is different than the solution set of the equation. The solution set of the equation has only one number, but in the inequality it could have one number, it could be phi, or it could have a lot of numbers. Just ask yourself, what are the numbers that smaller than negative 4? Okay? Let's see another example. Here, number B, 2x plus 9 greater than 1. If I want to solve this example, the same example, by an easier way like we used to. Let's see if I imagine that the 9 move to the other side. So the 9 will change its direction, its operation. Sorry, the 9 will change its operation and the 9 will be minus 9. So here I have 2x smaller than negative 8. The 2 will go to the other side and change its operation. The 2 here is multiplied, will change its operation to be divide 2. So here 2 will go to the other side and change its operation to divide 2. Here x smaller than negative 4. So in this example, I used the same example, but I used another method, the easier method. So here I will ask again myself, what are the numbers that are smaller than negative 4? So I will find that the solution set, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, and so on. Okay, another example. M minus 5 greater than or equal absolute value negative 7. Remember what is the absolute value? The absolute value of any number is positive. So here the equation will be m minus 5 greater than or equal 7. By using the easier way, so the 5 will change its place or will go to the other side, cross the sign of the inequality and go to the other side with the opposite operation. So here minus 5 will go to the other side and be positive 5, like this. Then the equation will be m greater than 7 plus 5 equal 12. So, solution set. Let's just ask yourself, what are the numbers that greater than or equal 12? What are the numbers that greater than or equal 12? So this sign is equal. So I will make the 12 I will put the 12 in the solution set because the sign of the equal. So let's think together, what are the numbers that greater than or equal 12? So I will start with 12. Why I started with 12? Because the sign of the equal here. 12, 13, 14, 15, 16, 17, and so on. So here all these numbers belong to the substitution set n. So this is a correct solution set. Another example. Here 1 minus 3x greater than 7, where x belongs to n. So my substitution set is n. So the answer of the solution set must be belong to n. It means that if I have a negative numbers, I will not put it in the solution set. So let's start solving. Here I have 1 minus 3x greater than 7. I will do my steps. So the 1 here will go to the other side, cross the other side. The 1 here plus 1 will go the other side and change its sign or its operation to minus 1. Minus 1. So here negative 3x greater than 6. Oh, do you remember? Alarm. Yes. Why alarm? Because here I have to move the number. This number is negative 3. We'll move to the other side by divide. So I will divide this side by negative 3 and divide this side by negative 3. So I will divide both sides by a negative integer. So this is alarm. Alarm. Yes. So what we will do here, negative 3 will cross the other side by divide negative 3. So I will divide by a negative number. So here x and 6 divided negative 3 is negative 2. What about the sign of the inequality? The sign will change its direction. The sign will change its direction. So now x smaller than negative 2. Just ask yourself, what are the numbers that smaller than negative 2? Numbers smaller than negative 2 are negative 3, negative 4, negative 5. Oh, but all these numbers are negative numbers. It doesn't belong to the n. So here solution set will be phi. But if he say, or if he want the solution set belong to z, so the solution set will be negative 3, negative 4, negative 5, and so on. Okay? And he may ask you in this exercise to represent this solution set on the number line like we used in grade 5. Okay, Junior 6, thank you for watching, and this was the last lesson in Unit 2. See you in next video.